Alright, in this lesson we are going to be looking at simplifying radicals. Our objective is to understand how to simplify radicals. Our vocabulary is a radical, the expression where the square root stays in the problem. Basically, we will be taking a square root and making it into a smaller form of a square root, because these square roots don't come out nice and pretty. They don't come out like the square root of 16 is 4. Instead, we get decimals that go on forever and never stop. So we have another way to write them. Our first example will be the square root of 18. To do a problem like this, we first want to factor 18. 2 divides into 18 and leaves us with 9. 9 divides into 3 and 3. What we're looking for is the prime factorization. So in this case, the square root of 18 is really the square root of 2 times 3 times 3. What we're looking for, because it's a square root, square is the power of 2, we're looking for duplicates, or 2 of the same number. In this case, 3 and 3 make 9. So we're going to square root 9. We've also still got this 2, so we're going to leave that in the square root, but off by itself, square root of 2, because that one doesn't come out perfect. So the square root of 9 becomes the number 3, and the square root of 2 stays square root of 2. So in essence, what we have is the square root of 18 can be written as 3 times the square root of 2. So this right here would be the simplified version of the square root of 18. We would go with 3 times the square root of 2. Another example we'll try is the square root of 120. So again, we're going to start by factoring 120. So 2 divides into 120, which leaves us with 60. 60 can be divided by 2, which leaves us with 30. 30 can be divided by 2, which leaves us with 15, which can be divided into 3 and 5. So our factored form of this would be the square root of 2 times 2 times 2 times 3 times 5. Again, what we're looking for is duplicates. So 2 and 2 make 4, so we're going to square root 4. There are no more, there's one more 2, so that becomes square root of 2. There's one 3, square root of 3. There's one 5, square root of 5. The square root of 4 becomes the number 2. The tricky part is with these right here. Square root of 2, square root of 3, and square root of 5. Well, we wouldn't write all 3 of them separate, so we can simplify them down into the same thing. Since we're always multiplying within our prime factorization, we just multiply these numbers together. So 2 times 3 gives us 6. 6 times 5 gives us 30. We have the square root of 30. So what we have here is 2 times the square root of 30 is the simplified version of the square root of 120. A third example is the square root of 72. Again, we have to start by factoring. So divide by 2, we get 36. Divide by 2, we get 18. Divide by 2, we get 9, which divides into 3 and 3. So our prime factorization is the square root of 2 times 2 times 2 times 3 times 3. Again, we're looking for duplicates. So 2 times 2 becomes 4, so we have square root of 4. We also have 3 times 3, which becomes the square root of 9. Then we have the 1, 2 off by itself, square root of 2. Square root of 4 becomes 2. Square root of 9 becomes 3. We're always multiplying in these problems because we're using prime factoring, which means we're multiplying. So we have 2 times 3 there. Square root of 2 just stays square root of 2 as it doesn't come out perfect. We can take 2 times 3 and make it 6, and we still have square root of 2, meaning that square root of 72 is known as 6 times the square root of 2. This can also be used in adding and subtracting radical expressions. So what we have here is 2 radical expressions, 3 plus the square root of 5 and 6 plus the square root of 5. So because we're adding them, what we can do is we can treat them like terms. If you think of this problem as 3x plus 6x, where the square root of 5 is like the x's, as long as we have the same square root, we can add the coefficients or the lead numbers, the 3 and the 6. So in this bottom version, it would become 9x. In the top, we do the same process. We can add the coefficients because their square roots are exactly the same. So 3 and 6 becomes 9. In the other one, we kept the x the same, and we'll do the same thing with the square roots. So this is 9 square root of 5. One last version of this would be if we first need to simplify the square root and then add or subtract. So here we have square root of 75 minus the square root of 12. So we're going to factor 75 and get 5 times 15, which can be divided into 5 times 3. So we have the square root of 5 times 5 times 3, which is the square root of 25 times the square root of 3, giving us a new version of 5 square root of 3 minus, then we need to factor 12, 2 times 6, 2 times 3, so this is square root of 2 times 2 times 3, which is the square root of 4 square root of 3. Square root of 4 is 2 times the square root of 3. So now both of these have square root of 3, so they would be considered like terms, meaning we could add and subtract the coefficients 5 and 2, making it 3 square root of 3. Alright, if there are any questions or any of this that we didn't understand, please pause, rewind, watch again, and bring your questions to class. Thank you.